Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have m to the power of 4 equals to 9, and we solve this problem for the values of m. So here you focus on one thing is that we have the exponent of this m is 4. It means that we need to find the fourth root of this question. So now we move towards to find these fourth roots. So here the very first thing we are going to do is we move this 9 to the left hand side of this equation, and it will be written as m to the power of 4 minus 9 equals to 0. And now in the next step we again rewrite this equation as, because this is m to the power of 4 and we break its exponent 4, and we write it as m to the power of 2 and its whole square, minus we write this 9 as 3 square, because we know that 3 square equals to 9. And after that here we have a nice square identity. So we use this identity, and we know that if we have a square minus b square, it is equals to a minus b times of a plus b. So we use here this nice identity, and in this question we have the value of a is m square and the value of b is 3. So now we substitute these two values of a and b in the below formula. So when we substitute these into below formula, so it will be written as in this form: m square minus 3, because we have our a minus b, so a is m square minus b is 3, into a plus b, and our a is m square plus b is 3, and this whole equals to 0. So after that here we have two cases, because these are two factors multiplied and equals to 0. So we have two cases, so that our first case is we write m square minus 3 equals to 0, and our second case is we write m square plus 3 equals to 0. So now first we focus on the first case, and in first case we have m square minus 3 equals to 0. So we move this minus 3 to the right hand side, and it will be written as m square equals to 3. So here we need to find the value of m, so that we take square root on both of the sides of this equation. So when we take square root on both of the sides, it will be written as in this form. So now you see here these 2 and square root are gone, and we get here m equals to plus minus square root of 3. So these are the first two real roots of the given question. And now in order to find the other roots, we need to solve this equation. So in this equation here we move this plus 3 to the right hand side, and it will be written as m square equals to minus 3. So now here again, in order to find the value of m, we need to take the square root on both of the sides. So when we take the square root on both of the sides, it will be written as m square into square root of minus 3. And you see here this 2 and square root are gone, and we get here m equals to, here we separate the square root on minus 1 and 3, and it will be written as square root of 3 into square root of minus 1. And we know that the value of square root of minus 1 equals to iota. So we will get here here we have plus minus, because we take square root on both of the sides. So you get here plus minus square root of 3 into iota. So these are the other two complex roots of the given equation, and these are the four roots of the given equation. And now we check these roots, is these roots are satisfied our given question statement or not. So here to check these solutions, we first substitute the real roots, and here our first real root is m equals to plus square root of 3, and our second real root is m equals to minus square root of 3. And now here we copy down the given question statement, and our question statement is m to the power of 4 equals to 9. So here we substitute the value of m on the left hand side, and we check the behavior. So we have the left hand side is square root of 3, so we substitute it here. Square root of 3 and its whole power 4 equals to 9. And when we convert this square root of 3 into exponential form, it will be written as 3 to the power of 1 over 2 into 4 equals to 9. And here we here we multiply these two exponents, and it will be written as 3 to the power of 1 over 2 multiplied by 4 equals to 9. And we will get here this 2 times of 2 becomes 4, and we have 3 to the power of 2 equals to 9. And here we obtain this 9 equals to 9. It means that this 9 equals to 9 satisfied our given question statement. So now we move towards our second root. So this is our second root, m equals to minus 3 square root, and we substitute it here and we check its behavior. So it will be written as minus 3 and its whole power 4 equals to 9. So we have the minus sign and its exponent is even number, so it will becomes positive. So we have square root of 3 and its whole power 4 equals to 9. So this will becomes our first case, this. So here we easily say that this is equals to 9 equals to 9. So our first two real roots are satisfy the given question statement, and now we move towards our complex roots. So our complex root, first we substitute the complex root is m equals to square root of 3 into iota. And now we check the behavior of this m, and our question statement is m to the power of 4 equals to 9. So we substitute it here, square root of 3 iota and its whole power 4 equals to 9. And now here we separate this 4 power here, and we get here square root of 3 and its whole power 4 into iota to the power of 4 equals to 9. And now in the next step, we need a little bit simplification here, and you see that this we know that this 3 to the power of square root of 4 is equals to 9. We will find the above case. So this term is equals to 9, and here we have iota square and its whole square. We write it as iota square and its whole square equals to 9. And we know that the value of iota square is minus 1, so it will minus 1 square equals to 9, and minus 1 square is plus 1, so we have 9 equals to 9. So the value of m equals to square root of 3 iota is also satisfied the given question statement. And similarly we will check our fourth root, and it is m equals to minus into square root of 3 iota. So when we substitute this value here, it will becomes minus square root of 3 iota power 4 equals to 9. And here this is equals to square root of 3 iota and its whole power 4 equals to 9, because this minus 1 is eliminated because we have the even exponent. So this is equals to 9, we prove here, and both of the sides are equal. So this shows that these four roots are satisfied our given question statement. Okay, these four roots satisfy the given question statement, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.